And then we're going to do something brand new that's kind of the heart and soul of what this chapter is. All right, so here we go. It says the zeros, that means x is -1, x is 2, x is 4. Those are the zeros of the polynomial. That means that if you graphed it, you have a dot at -1, 0, a dot at 2, 0, and a dot at 4, 0. So now that I've explained what the given is, can you write your equation? Yeah. Chris?
Is this on the paper or you?
Yeah, no, it's on the paper. It's D. It's 2D.
Oh.
This is 2D. It says the zeros are given. The zeros are the x-intercepts. So what are my parentheses? X plus 1, x minus 2, x minus 4, right? Now, it says I contain the point 110. What am I going to do with that piece of information? That's my plug-in point. So 10 equals n times 1 plus 1, 1 minus 2, 1 minus 4. So 10 equals n times 2, -1, -3.
Bless you. Bless you.
So 10 equals n times 6. So what does n equal? 5 over 3. 10, 6, which is 5 over 3. And there's your answer. So that's exactly what you did on the quiz. The only difference is I gave you the roots. Instead of giving you the graph, I gave you the roots. Are you okay with that? Now you just took a quiz and acted like you knew what you were doing when the directions said sketch. I hope you did. I think you did. These directions say sketch. What's the difference about this question and the one on the quiz? Yeah, they're not factored, right? So before we can sketch this, we need to factor it. Now, we've talked about this before. We haven't done a ton of it, but we talked about it. How do we factor something like this? Grouping. We're going to group them. So we'll look at the first two terms, because, wait a second, in order to graph it, don't you want it to look like this? So you know where to put the dots? That's why we're factoring this, so that we can get parentheses and know where to put the dots. Okay, so what can I take out of these two? X squared. Oh, what can I take out of the last two? -1. Very good. And when you take out a -1, it's going to make this a positive and this a negative. Now, what really wonderful thing just happened? The parentheses match. If they don't match, it doesn't work. You can't do it. Or you've made a mistake. They match. So I write down the match. And then I have another parentheses that I put everything else in. So here's the match. I wrote it down. Now what's left? X squared minus 1. And what do you know about x squared minus 1? It factors into x plus 1, x minus 1. That is what you're sketching. Now that we have it all factored out, sketching it is going to be a breeze. I hope. Where am I going to put my x-intercepts or my dots? At -1, +1, and +4. What power have we got in our problem? 3, which means start down up. So we're going to start down here. Is anything squared in my factors? Anything squared? Which means every time I hit, I just go through. So I'll go through, go through, go through. That wasn't so bad, was it? That's a little scary. Let's try the next one. Do you think we can do something similar with this one? What's your thought on that? You think we can group it? Yeah, we can. All right, so let's group the first two. What can I take out? X squared. And if I take out x squared, I'm left with x plus 3. All right. What about the last two? Negative 4. And what am I left with? X plus 3. That works out nicely, doesn't it? Remember, if the parentheses don't match, either you haven't done it right or it's not possible. They have to match. So we have x plus 3 is our common factor. Now what's going to go in my other parentheses? This is my common one. I wrote it down. What's going to go in my other one? X squared minus 4. Which factors as plus 2 minus 2? Now, can you graph that? Of course you can. You're getting good at this. You're going to put dots. I should call them x-intercepts at negative 3, negative 2, and 2. Now what else do I have to pay attention to? It's a cube. Any bouncing going on here? Nope. So we're just going to sketch it in. Up we go, down we go, up we go. There we are. We connect the dots. Connect the dots with a nice smooth line. Go through every dot. That's it. What do you think? Easy enough? Would you try C on your own with your neighbor? How do you want to do it? Try C. It should be about the same thing. I did get a little bit tricky with that one, and I threw in an extra 2. Did you see that? Did you notice that? So if you have that, just put it in front. Yeah, I just put it out in front. That's where we normally put our extra numbers. So I could have started this. In fact, I did start it and then erased and started over. You can do this a couple of different ways. I went ahead and just grouped it the way it was. So that meant I could take a 2x squared out of the first two and a negative 8 out of the second two. And that left me with this. We're going to have my common parentheses. Okay, so is everybody okay to hear? factor this more. So I took a 2 out of it, and that left me with this, which broke down into this. And I moved the 2 out to the front because that's just like proper form. That's just where we like to see it. And that's what I ended up with. Right?
How come on the first step there's 2x minus 1s? And then the second step it's still
Because you factored it out. It's like if you have a 2x plus a 3x. You can factor the x out. It's like undistributed. It's like reverse distributive. So there's only ever going to be one. Whatever is in common, write it down one time. All right, now did you sketch it? Here's a point I want to make. Is there an x hooked to that 2? I mean, does that 2 have an x like this guy has one? No. He doesn't, he's not a 0. I don't graph him. I just plot 1, 0, and negative 2, 0, and 2, 0. The only time, well, you're never going to plot that 2 or 3 or negative 8 or whatever it is. You're never going to plot it. You only plot it if it's got an x. Okay? The only time it's going to matter to you when you're sketching is if it happens to be negative. Because we know if it's negative, it will turn it upside down. But you're not even going to worry about that 2. You're going to say this problem was a cube. It starts down, ends up, nothing squared, and that's the answer to the question.
If you didn't put the 2 out, would it change anything?
It would change if we were actually plotting points to graph or doing it on a calculator. Yes, it would make a difference. For us, in this kind of sketching, no difference. So, what I'm trying to say, Quincy, is for us in our sketching, if that had been a 3, you sketch it exactly the same way. The only time you wouldn't sketch it that way is if it were a negative 3. Then, of course, you turn it upside down. Okay, so good with that step, everybody? Because now we've hit the big time. Take a look at number 4. And if you're awake and paying attention, you're looking at number 4 saying, well, looks just like all the rest of them, Mrs. Ford. And you are right. It does look like all the rest of them. Except for one thing. Well, yeah, I've added, you don't even know what that means. I'm going to tell you in a minute. But just looking at the problem, what's a little bit different about this one? You cannot factor it by grouping. Now, you can say to me whatever you want. Mrs. Ford, I can take an x squared out. Yes, you can. Mrs. Ford, I can take a negative 1 out. Yes, you can. But what does not happen that needs to happen? The parentheses don't match. So I'm not saying that you can't do some factoring. You can. But it's not productive. It doesn't do anything for you. So, when we do this sketching, the purpose of the factors is to tell me what numbers I can put in and get 0. If you put in a 1, you would get a 0. If you put in a negative 2, you would get a 0. So the purpose of the factors is to tell me what I can put into my problem and get 0. Because those are the points that I want to graph. Well, we're going to guess. We're going to guess numbers that we can plug in that will give us 0. Now, I'm going to say that again, and kind of in a daze, but I want you to think about it. We're going to guess numbers to plug in and get 0. Now, what scares you about that?
How long it could take?
How long it could take, because aren't there a lot of numbers out there in the world? Yeah, we could guess for a very long time. It could be bad. So luckily, that little PRR thing there stands for possible rational roots. Have Have you done this before?
No.
Oh, it stands for possible rational roots. So possibilities. So instead of you having to just guess every number in the whole wide world, I'm going to narrow it down. I'm going to give you a bucket of numbers. Now, there's still going to be more than, you're still going to have to do some guessing, but it's better than having nothing to narrow down. PRRs, possible rational roots, come from factors of the constant, and by constant, I mean the thing with no x, that's called the constant, over factors of the leading coefficient. And the leading coefficient in this problem is a 1. The leading coefficient is the number attached to your big power, your biggest power. So, what are the factors of 6?
3 and 2.
Plus or minus 1, 2, 3, and 6? And by factors, we mean what could you divide in and not have a remainder? Can you divide 6 by negative 2? Yes, that's why it's a factor. These are the factors of 6. Over, what are the factors of 1?
1.
Plus or minus 1, that's it. There they are. So you have 1 over 1, 2 over 1, 3 over 1, 6 over 1, plus or minus. Positive or negative. All right, so now we got our pool of numbers. We have our little bucket of numbers we're going to try. You're going to plug them in, and feel free to use your calculator. You're going to plug them in, so maybe we'll plug in 1. Let's plug in the number 1. I'm just picking numbers out of my pile. If I plug in 1 for all of the x's, this guy always confuses me, so I'm going to take him out. If I put in 1 for the x's, I have 1 cubed plus 2 times 1 minus 5 minus 6. Is that going to add up to be 0? I don't even care what it adds up to. Is it going to be 0? No. So that was a bad guess. All right, let's try negative 1.
Wait, hold on, this 4?
Yep.
In the first problem, that plus 2, wouldn't it be plus 4?
I'm plugging in 1.
Yeah.
So I have 1 cubed, and then I have 2 times 1 squared. What's 1 squared? Remember, you do the power first. You do the power first.
I got you.
But now I'm doing negative 1. So I'm going to have negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. Okay. What's negative 1 cubed? Negative 1. What's negative 1 squared? Times 2. What? Does it work? Is that what you're getting excited about? So now I have a plus 5 minus 6. And we got all kinds of excitement happening over here. Well, first of all, Deshani's back, and that's exciting. But second of all, we have equaling 0. So you have found one of your factors. Kids, your job is to graph this problem. Okay? You have now discovered that one of your zeros is going to be at negative 1. If you plug in negative 1, you get 0. So one of your factors would be x plus 1. Would you agree with me? That would give you a dot at negative 1. Quincy, my man. Mm-hmm. Yeah. Exactly. That's what I was thinking.
No, Mr.
Is that how we behave in a football game?
Mr. Gomez does this to us all the time.
Yeah. It's stupid that you think you can do it in math class.
Whoa.
You are gonna be JB for the rest of your life. Okay, now,
Too loud.
we've got a 0 and -1. Okay, now the next step. I gotta erase this because I gotta keep it on this board. The next step, we're going to do synthetic division. Do you remember that from last year? Synthetic division. Okay, here's what we do. I want you to write down these numbers. 1, 2, -5, -6. Write them down just like that. 1, 2, -5, -6. Out here in a little box or a circle or whatever shape you're used to using,
I remember this.
we're going to put the -1. We're going to put the number that gave us 0. Now, that 1 right there drops straight down. And sometimes it helps to actually make an arrow to remind you that number comes straight down. Now we multiply -1 times 1 and we write the answer here. So -1 times 1 and then we add. So adding would give me 1. Now -1 times 1.
-1.
Adding
-6.
-1 times -6.
6.
Adding.
0.
And that is the remainder. And that's a good sign. When the remainder turns out 0, it means you have a factor. Which we thought we did, because we guessed, right? Now, what's this? A new equation. And the new equation is x squared. Now, why is it x squared? Because we divided an x cubed, right? It goes down by 1. So x squared plus x minus 6. Does that factor? How does that factor? X plus 3, x minus 2. And those are your other two factors. Now you're ready to sketch it. So I'll put a 0 at -3, a 0 at 2, connect my dots, and you just sketch the problem that's hard. I don't know, just chill out. You're done when I tell you. Harley?
Never mind.
All right, so on next time I see you, which is Monday, we will recap this, okay? And do a bunch more practice. Chris, will you turn the video off?
Yep.
Thank you.